Hello everybody. We start with the new chapter in maths today for standard 9th ICSE, that is circle. Uh, Now the chapter circle was originally in the 10th standard portion, but since last 2 years they have switched a part of the chapter to the 9th standard and part they have kept it in the 10th standard. So that's why understanding this chapter becomes more important, because if you do not understand the 9th standard part of it, then 10th standard becomes difficult automatically. So that's why the importance of this chapter is not only for the 9th standard but also for the 10th standard, because partial chapter is there in the 10th standard and partial it is in the 9th standard. Talking about circle, we know that circle is a closed figure. So it is a closed figure it is such that it is equidistant. All the points on the circle are equidistant from a particular point. So that particular point over here is the center of the circle, and the distance between any point from the center of the circle, that is equal, and that is called as the radius. So radius is the distance between the center of the circle and the circumference of that circle. So that distance between the center and the circumference is given as the radius. Accordingly, if I have got any point, suppose I have got a point, let's say A. Now, and if it is given that OA, that is a distance OA, if it is equal to the radius, then this particular point A will lie on the circle. So there will be A will be here. So this is on the circle. Okay. Now, if this OA is greater than R, then it will be somewhere here. So automatically this point over here is A, and that is why it will be in the exterior of the circle. So the point which is outside the circle, that means if the distance between the point and the center of the circle is greater than the radius, then I say that the point is in the exterior of the circle. So that's why OA, if it is greater than the radius, that is this distance from here, this distance from here to here, if this distance over here is greater than the radius. So this OA is greater than radius. And if the OA is such that is less than the radius, that is somewhere here, if this is the condition, this is A, then this over here is OA is less than the radius, then it is called as in the interior of the circle. So basically the circle has got three sections. One which is inside this particular area is called as the interior. Okay. The one which is on the circle is called as on the circle, or the circumference on the circle. And the one which is outside over here in this area out here, that will be called as the exterior. So accordingly, the circle divides a plane into three parts, that is the interior of the circle, on the circle, and the exterior of the circle. That is, the plane on which the circle lies is getting divided into three sections. The interior, which has got the distance between the center to that point is less than the radius. The exterior, which is center to the point, is greater than the radius, and it is the last one that is equal to R, which is on the circle. So that is about the circle interior and exterior elements. Then we see the next thing is about the different parts of that particular circle. So now we know that in a circle, if I can see that circle is a closed figure. So now, firstly, if this is a circle, then we have a line which is joining two points of the circumference of the circle. See, a line joining any 2 points on the circumference of the circle is called as chord. Okay, it's chord. Chord is the segment which is joining the two points on the circle. Now, if this chord is such that it is passing through the center, so if it is like this, if it is passing through the center, then this chord becomes the diameter. So diameter over here is the longest chord. So diameter is longest chord. Okay, and the value of this is equal to diameter is equal to twice the radius. So diameter is equal to twice the radius, or 2r. D is equal to 2r can be the formula for the diameter. The next one we see is that if this is not a segment, but if it is a line, okay, if it is a line which is passing like this. So a line which is intersecting the circle at 2 points, a line which intersects the circle at 2 points, A and B over here. So the line which is intersecting the circle at 2 points, such a line is called as a secant. Okay, it's called as a secant. We have learned in the trigonometry part that sec, okay, sec, S-E-C, that is nothing but the secant. So secant is this particular secant which we are talking about. So secant is this particular line that is touching the circle or intersecting the circle at 2 different points. That is a secant. And if I see a line which is touching the circle at only one point, if it is just one particular point over here, then such a line over here is called as a tangent. So tangent is the line touching the circle at only one point. So if the tangent, if there is a line which touches the circle at only 1 point, then we call that line as a tangent. Yes, trigonometry का tan, T-A-N, tan trigonometry का जो है इसका full form is tangent. Okay, so that is how you can see tangent touching the circle at only 1 point. So it is not intersecting the circle; it just touches the circle. Whereas secant intersects the circle at 2 points. That is going to be the secant. So that is secant. Now, the next is, if I take any particular 2 points on the circle and the curved part over here, this is the curved part over here, this is called as the arc. Okay, the curved part over here is called as the arc. Of course, this is dividing into 2 parts. One is this part and the other one is the bigger part. So the smaller part what you see over here is called as the minor arc. This is the minor arc, and the but bigger one is called as the major arc. So major arc and minor arc. Minor arc, the smaller arc. The one which is formed by the smaller arc is called as the minor arc, and the one which is forming the bigger part of the circumference is called as the major arc. So minor arc and major arc, you can say over here it is minor arc AB. So if this is the point A and B, then it is minor arc AB and major arc AB. So that is how you are going to write this thing. You can add one more alphabet over here, like for example T over here. So you can see major arc ATB. ATB can be the ATB. This could be the major arc. And similarly, if you put an X over here, it will be minor arc AXB. So you can also identify by putting a point on the in between the arc, and accordingly you can name it as arc AXB and arc ATB, so that you can identify more easily minor and major arcs. Now, apart from this, if it is exactly the center, so now if this is the center, so this is P and this is Q, then automatically we know that PQ is the diameter, then it is dividing it into 2 equal halves. So the circle is divided into 2 equal halves, and hence they are called as a semicircle. So semicircle is the one which is half of the circle, half circle. So it is semicircle, which is exactly the one which is going to be formed by the diameter. So when the diameter is the chord, the arc which is formed by the diameter is called as the semicircle. And of course the complete circle ka jo perimeter hai, that is called as the circumference of the circle. So that is the circumference of the circle. Now we see some more things, and that is about the sectors. So now we will have now since we are in the chords, it is better that I'll make you understand about this thing first. Now the chord has divided the circle into 2 parts, the bigger part, that is the major arc, and the minor arc. Accordingly, the area which is over here, this area what is over here, this area is called as the minor segment. Okay, this is the minor segment which is formed by the minor arc and the chord. So the chord in the minor arc forms the minor segment, and the bigger part is called as the major segment. So the major segment and the minor segment are the names given to the internal area of the circle which is going to be within the arc and the chord. Arc and chord के बीच में का जितना भी area है, that is called as the minor segment for a smaller part and major segment for the bigger part. So minor segment and major segment is about that part. And similarly, you can also see that I'll just erase this part. Now, one more thing what we can see is if I draw, suppose this is a circle and I have got a chord over here like this. This is A and this is B and this is the center O. Then this chord is going to give you this particular kind of this particular point. A and B are going to give a particular point at the center. So the area over here is called as the minor sector. Okay, this is the minor sector, and this part, the bigger part, is called as the major sector. Okay, so sector is the angular part. So pizza का जो piece cut करके जो मिलता है, that is the one sector. So that one sector over here. So this is a sector. So you look at like a pie chart or a pizza, that particular piece what you see is nothing but the sector. So what we are actually drawing in case of a pie chart are the sectors. So the sectors will be the one which is having a particular angle at the center. So that is the angle subtended. Now this angle over here is called as the angle subtended at the center. Okay, so angle subtended at the center means angle formed by this particular arc or this particular chord at the center. This particular chord or this particular arc is going to subtend an angle at the center. So this angle which is formed by this arc is called as the angle subtended at the center. Similarly, there could be angle which is subtended at the circumference. So this is the angle subtended at the circumference. So it is angle subtended at the circumference. So this is the angle subtended at the circumference by this chord, this arc AB. So that is angle subtended by the by the chord or by the arc at the center or at the circumference. So that is the angle subtended by the arc or the chord. Then we see some different kinds of circles. So we know that different kinds of circles you will be having. The first one is not kinds. I will not call it as kinds. I will just say that if I got two or more than two circles, then they can be forming different kind of structures. Like for example, if they have got the same center, so if this is one circle, this is another circle, and this is the third circle, all of them have the same center, then such a one are called as concentric circles. Okay, circles having the same center, concentric means same center. So circles which have got the same center, then but different radiuses. Okay, the radius over here is small, then bigger, then more bigger. So if it is going to form circles with the same center but different radius, the circles so formed are called as concentric circles. Now similarly, if I have got two circles who has got the same radius, if the radius of both the circles is the same, this is also R and this is also R, or maybe this is 5 and this is also 5, then I can say that they are equal circles. So equal circles are the one which has got equal radius. Those circles which has got the same radius will be equal, because there is no other way they could be equal, because once the radius is same, then automatically you cannot draw any different kind of a circle which is not of the same kind. So circles with the same radius are equal circles. And another thing would be if I got circles such that they are going to be like this, then these are circles touching each other externally. Okay, touching externally. Okay, they are just having one particular point common in them. If it is like this, then it is touching each other internally, internally. So if they are touching internally, it is this kind. They are touching at only one point internally. And if they are like this, then it is called as intersecting. Okay, these are intersecting circles. So that means they are cutting both the circles are cutting each other at 2 points. If they are touching each other at one point, it is touching externally, one point internally over here. If they are cutting at each other at 2 points, then they are called as intersecting circles. Now this you will not require much, but normally what happens is that if the figure of that particular sum is not given to you, okay, if the figure is not given to you and you are asked to draw it based on the question. So in the question they can tell you that two circles which touch internally, or two intersecting circles, then you should imagine that okay, the circles are like this, and then there is a common chord. So common chord kya hoga? Will be a chord which will be common to both of them. So this AB is common to this circle also and this circle also. That's a common chord. This is how we are going to have the different kind of sums which will be there, and then you are going to find out the values of it. So this was about the general properties of the circle. So we saw in the circles, first one was the chord, then the diameter, which was the longest chord, the radius of course, and then we saw the tangent, secant, then we saw the minor arc, major arc, minor segment, major segment. Then in the angle properties, the angle properties was the angle subtended at the center, angle subtended at the circumference, and also that angle formed a sector. So minor sector, major sector. Then the types of circles: concentric circles, equal circles, touching it externally, touching internally, and intersecting kind of circles. So these are the different properties of the circles. Now we move on to the next part, and that is the main part of the chapter, that is the theorems which we are going to have for this particular chapter. Now there are, in the first exercise, before we do the first exercise, we will need to understand 5 different theorems. Now if you are not able to understand the theorems, you cannot do circles. So theorems are the most important part of the chapter. Now what we are going to do is, we are having 5 theorem. Out of the, actually speaking, there is only 3 theorem, because the first theorem जो है उसका ही उल्टा, that is the converse, is the second theorem. Third theorem का exactly ulta, that is the converse of that, is the fourth theorem, and then there is the fifth theorem. Fifth theorem is something which you normally don't use. So that's why there are, no doubt there are 5 theorems, but actually speaking there are only 2 theorems which are really required to understand. Now most important is not only to understand the theorem, but also to know the proof of the theorem. There can be a question in your paper that prove the theorem. You can just, they may not even say prove the theorem, they can just say prove that the straight line drawn from center to chord bisects the chord. Okay, that is just that phrase given to you. So for that, what you need to do is that draw the figure, write out the given things, write down any construction, prove that thing, and hence proved. So accordingly, there could be a 3 mark or a 4 mark question just to prove a particular theorem. So the proof of the theorem which are given over here, that is right from page number 325 to page number 337. In fact, 327 you may skip it, but 325 and 326, there are 4 proofs given for the 4 theorems. So all those 4 theorems ka jo proof hai, you will need to learn it by heart properly, so that you can write it in your examination whenever you are asked to prove that particular theorem. So that is how we are going to have in the theorem. Let's start with the first theorem. Now, all these theorems what we are having are based on chords. So that's why the theorems can be said to be as chord properties, or properties of the chords. So that's why chord properties of the circle is the subheading given to this particular part of the chapter. So chord properties is what you are going to learn. So first of all, let's see that if I got a circle. Now, if I got a circle over here like this, and this circle, and I got a chord over here like this. So there is a chord over here which is like this, and then you got, that is chord AB, and this is the center O. So this is what is given to me. Now the theorem states that the straight line drawn from the center of the circle straight line drawn from the center of the chord to bisect the chord which is not a diameter is perpendicular to the chord. So if I draw a straight line from here which is such that it bisects the chord, that means if this part is equal to this part, so it is given that given part over here is that OM is perpendicular, sorry, it is not perpendicular, I need to prove that it is perpendicular. So it is given that AM is equals to BM. This is the only part which is given, and I need to prove that that OM is perpendicular to AB. So this is what we need to prove, that OM is perpendicular to AB. So the theorem states that the straight line drawn, a straight line drawn from the center of the circle to a chord, bisecting the chord. That means if I am drawing or if I am joining the point O to M, which is the midpoint of AB, then it is found that OM and AB are perpendicular to each other. This is what the theorem means. Now let us find out how to prove this part. So to prove this part, first of all, we will have a construction. So in that construction, what we are going to do is draw this OA and OB join करेंगे. So join OA and OB. This is what I need to do over here. Join OA and OB. So basically what I am planning to do is I want to prove that this is 90 degree. Now how do I prove it in 90 degree? If I prove that these two triangles are congruent, and if this and this are equal, so automatically they are already forming a linear pair. So that's why it will be 90 degrees. This is the basic idea what I am going to do. I am going to prove the two triangles to be congruent. Accordingly, by CPCT, this angle and this angle will be equal. If these angles are equal and they are forming a linear pair, they will be 90 degrees each. Okay. So let's see how to write it down. Now, so you write over here in triangle AOM and triangle BOM. Okay, so there is triangle AOM, that is this triangle, and triangle BOM, that is this triangle. You can see over here what are the things you already know. You know that this two, that is AM is equals to BM given. You also know that OM is common to OM. OM is equals to OM because it is common. Now what is the next thing what we have? Do we know this triangle? No. Do we know this angle? No. Do we know these angles? No. So it is only OA is equals to OB which is balanced. Yes, it should be equal. OA is equals to OB. Why would they be equal? Tell me, what will be the reason that they are equal? Yes, it is the radius. OA and OB are the radius of the circle. This is also the radius and this is also the radius. Accordingly, they will be equal. So it is the radii. These are the radius, the radii of the circle. Okay, OA and OB are the radii. So that's why we see the triangle AOM is congruent to triangle BOM by which test? SSS. So it is SSS test. Once this triangle and this triangle are congruent, automatically these two triangles are also equal because by CPCT. So angle OMA is equals to angle OMB by CPCT. But we also know that OMA plus angle OMB is equals to 180 degrees because they are linear pair. Hence we find that angle OMA is equals to angle OMB is equals to 90 degree. Therefore OM is perpendicular to AB. This is what was to be proved. Okay, so this was your first theorem. So the first theorem states that a line drawn from the center of the circle to bisect a chord will be perpendicular to it. So which is not a diameter because it should not be a diameter. It is over here. It cannot be the diameter because this is perpendicular over here. So chord, if it is a diameter, it will be here. तो फायदा ही नहीं है. ऐसे भी O तो सेंटर ही होता है, तो फर्क नहीं पड़ता. So we are talking about a chord which is not the diameter. Okay, that's the first part of the theorem. So that's the first theorem. Now we see the second theorem. The second theorem is exactly the converse of the first theorem. Okay, what is the converse of the first theorem? यानी क्या, जो मेरा given है वो मुझे prove करना है और जो मेरा to prove है वो मेरा given हो जाएगा. So it will be this way that this becomes to prove that and this becomes given. Okay, so it is already given to me. So this is not given to me that they are equal, but it is given to me that these are perpendicular. So it is given that this and this are perpendicular. This is given to me that OM is perpendicular to OB is given, AB is given to me, but I am not given that AM is equal to AB. I need to prove that AM is equal to OB. I am going to use the same thing, same fundamental principle. I am going to prove these two triangles to be congruent. Once the two triangles are congruent, automatically then AM will be equal to MB. So here again we are going to use the same two triangles. We don't know this, so I cannot use this thing. Right? Okay, this much part will not be required. The test will be different. So, what do we have over here? Let's write it in a different color so that you can understand this one. So now, given is OM is perpendicular to AB, therefore, we will say that angle OMA is equals to angle OMB given. Okay, given perpendicular. So perpendicular given or given perpendicular. So that is equal to OM is equal to OM. So this is equal to this, and this is 90 degree, and this is the radius. So what is the test which you are using? What is the test you are using? It is RHS. So it is congruent by RHS test. So by the congruency of RHS test, we are proving these two triangles to be congruent. If the two triangles are congruent, then automatically AM is equals to BM by CPCT. So that's the end of the second theorem. So second theorem states, what does it state? That perpendicular to a chord from the center of the circle is bisecting the chord. Okay, perpendicular drawn from the center to the chord, from the center to the chord bisects the chord. Okay, so that is perpendicular to a chord from the center of the circle bisects the chord. So that is what we are saying. If I am drawing a perpendicular from O on AB, it will be seen that OM will also be the perpendicular bisector. That means it is going to become AM is equals to BM. So these are the two first theorems what we are having in this particular chapter. Now we continue with the next two theorems. Next three theorems are there, but I think I'll take it in the next video.